Yeah.
Thank you. So we want negative b. My b is already negative. Remember, it's ax squared plus bx plus c equals 0, right? So a is 2, b is negative 5, and c is 3. So I've got a negative 5 plus or minus square root of negative 5 squared minus 4 times 2 times 3 over 2 times, that's just the setup, right? Now it's just doing the math. Negative 5 gives me a 5. Plus or minus, I have 25 minus 24 gives me the square root of 1 over 4. Square root of 1 is equal to 1, so I have 5 plus 1 over 4, or 5 minus 1 over 4. So that gives me 6 over 4, which is 3 over 2. 4 over 4, which is 1. How'd we do?
I messed up. I added third subtract.
Oh, right here? Okay, yeah. So you had 49, and you had a 7. right? So sometimes there's nothing to like, oh wait, that ain't right. It still gave you a nice square number, and that's gonna make you think. So this time again, my b is negative, so I've got a -6, plus or minus. That's where my two answers come from, plus or minus. -6 squared minus 4 times 4 times 9. Did it again. Over 2 times 4. So I've got a 6 plus or minus. We've got 36. Let's see, 16 times 9. It's going to be a 144. Checking my math, guys. Minus 144. What do I get for 36? Minus 144. 112 over 8. Okay, I am looking for a square number that will go into 112. Can I get 4 out of there? That would give me a 11 would be 8. That would give me an 18. So I would say 6 plus or minus the square root of 4 times the square root of -18 over 8. What's the square root of 4 gonna be? That's a 2, right? So I'm gonna take this and divide it all by 2. So my answer is gonna end up being 3 plus or minus the square root of a -18 over 4. Yes? Plug into your formula. Know your formula. Plug into that formula and then just work the math down until there's nothing else you can do, right? Don't assume because you got here that you can't simplify it some more, okay? All right, the only other thing from 1-2 that we did not talk about that I'm going to is called the discriminant. And that comes straight out of the formula also. That's what you see under the radical. The discriminant is going to be your b squared minus 4ac. Whatever number you get right here. And that's going to tell me, like if I have a quadratic equation, I have a graph that's a parabola, right? That U-shaped graph. And what I've been trying to find every time I solve a quadratic equation, what I'm looking for is these 2 points right here. Where does it cross the x-axis? That's my x-intercepts. That's what I'm looking for. Sometimes my parabola, though, it'll come down and it'll only touch at 1 point, right? There's only one solution. Or maybe it's going down and it comes up and it only touches at 1 point. So sometimes we just have one solution. Most times there's 2 real solutions. Sometimes, though, Maybe it's all the way up there and it doesn't cross the x-axis at all. And then we're going to say it is no solution. Okay? And I can find that out by using this number right here. If the discriminant is greater than 1, in other words, it is positive. If whatever number I get is a positive number, I am going to have 2 real solutions. Okay? If it is equal to 0, then I am going to have 1 real solution. But if it is less than 0, in other words, it is negative, then I'm going to have no solutions. So just like that last one we did right here where it came out negative under here, I know that my graph is going to look something like this because I have a negative up under my radical. So it's going to look something of that nature. If I have 3 halves and 1, that's 2 solutions. I know that I'm going to have a graph looking something like this one. Okay? So a test question or a quiz question might be use the discriminant to determine how many solutions there are. Okay? And you're looking for, is it greater than 1? Is it positive 2? Is it equal to 0, 1? And if it is less than 0, if it's a negative number, it's going to be none. So what if I have x squared minus well, how many solutions am I going to have? Use the discriminant to determine. Remember, that's just this part right here, b squared minus 4ac. My b minus 4 times 1 times 9. So I get 36 minus 36 gives me 0. So that tells me I'm going to have just 1 solution, right? My graph, my parabola is going to come to the x-axis, touch it one spot, and turn and go back again. Okay? All right, before I move on to start 1-3, do you guys have any questions from 1-2 on the quadratics? From 1-1 on the solving equations? No? Okay. All right, so 1-3, complex numbers. Let me get rid of this. Complex numbers are dealing when you have a negative under the radical. Like if you had x squared minus 9 is equal to 0. And you're going to add that 9 on both sides, and you say x squared is equal to 9, and you take the square root of both sides, right? And you can because I got two numbers, x, positive 3 times positive 3 gives me a 9, and negative 3 times negative 3 gives me a 9, right? So I have a plus or minus 3. However, what if this had said x squared plus 9 equals 0? And I subtract the 9 from both sides. Now I've got x squared is equal to negative 9. And I go to take the square root. But my problem is positive 3 times positive 3 makes positive 9. Negative 3 times negative 3 makes a positive 9. But there is nothing that I'm ever going to multiply by itself that's going to end up being negative. There is no number times itself that'll be negative. So what I cannot have is a negative under this radical. Okay? We got to remember that. So what did we do in order to deal with it? We come up with complex numbers. And we use I for imaginary, because these numbers don't actually exist. Okay, we call them imaginary numbers. And we've got 4 that we've got to memorize. We got to keep in. Why aren't you? That's what I'm looking for. I is equal to the square root of negative 1. I squared is going to be negative 1. I to the third is equal to, whoops, this should be a 1. Negative I, and I to the fourth is going to equal a 1. These are the 4 that you've got to have stuck up here. These are the 4 that you are going to have to know off of the top of your head. I'm going to ask you a question like, what would I to the 17th power be? What would that equal? Well, you're going to use those properties of exponents. Do you remember when you were doing a to the second times a to the third? When you had the same base, what did you have to do with those exponents? This is 2 a's, and this is 3 a's, so this is actually a to the 5th power, right? And all we had to do, the shortcut, was to add those exponents. This is a to the 2 plus 3, right? So I'm going to do this backwards. I want to break this into 2 different i's. I want my biggest multiple of 4, because 4 is my golden child right there, because 4 gives me a 1, right? So what's my multiple of 4? That's less than 17. What's the biggest multiple of 4?
12.
I can go one more.
16.
16?
Yeah.
So that would be I to the 16th times I to the 1, right? Because 16 plus 1 is still 17. All right, 16 is a multiple of 4, so this whole thing right there, that's just a 1. Right? And I to the 1 is the square root of negative 1. And 1 times the square root of negative 1 is the square root of negative 1. Right? Give me a number. I to the...
So that equation done?
Mm-hmm. I want you to simplify this. There's your answer.
So it's just one.
Mm-hmm.
Okay.
Because I took out all of that, so it just left me with I to the 1st power, and I to the 1st power is... Mm-hmm. What did we view? 37. Multiples of 4. What's the biggest multiple of 4 that comes up under 37? 36. So I'm going to break this down to I to the 36th times I to the first, and we're going to get that same answer. Yes? Okay. When I am doing adding and subtracting, besides simplifying, I'm going to have to do some operations with this. So if I'm adding and subtracting, I want my answer to be in the format of A plus BI. In other words, I want the constant first, and I want any term with the I in it to be second. But I am just going to treat it like any other variable and collect my like terms. So let's say that I have 2 plus 3i plus 7 minus 2i. In front of both parentheses, it's positive. So I can drop those parentheses and say 2 plus 3i plus 7 minus 2i. Who are my like terms?
3 and 2.
Okay, 3i and 2i, that gives me, because that's a negative, so that gives me a 1i. What about 2 and 7? They're both positive. A plus bi. Okay, that's my answer right there. I'm not solving anything, I'm just simplifying. Now, on both of these, there was positive in front. What if it is a negative? What if I have 8 plus minus?
Switch the signs.
I do have to switch those signs. Why? Because I've got to distribute a -1 there, right? These parentheses here I can drop because that's positive in front. So I can drop that. I can just write that as A plus 2i. But this is negative. So the only way I get to drop them is to distribute that -1. So -1 times 6 is a -6, and -1 times -3 is a positive. So now I got to do again. Collect those like terms. +2, +3 gives me a +5i. 8 and -6 gives me a 2. Yes? All right, let's try 2 more. Both of these are positive. So I'm gonna have 2 plus 6, negative 3i plus 8i. Doing a little commutative property, moving things around. 2 plus 6 gives me 8. A negative 3, a positive 8. And it's in that standard form of a plus bi, just wanting the constant first and the I term last. I'm gonna bring down my negative 3 plus 2i here. But I'm not gonna bring down a positive 4, that's gotta be a,
Negative.
and, right? So a negative 3 and a negative 7, 4 is gonna give me that negative 7. And then 2 and 4 is gonna give me a 6i. Yes? Okay. Sometimes we gotta multiply them. When it comes to multiplying, the most important thing you have got to remember, where we lose points on this, is that I squared is equal to a negative 1. Remember FOIL, first, outside, inside, last? All right, so what if I were doing 2i times 2 minus 3i? When I get here, my first, I'm going to have 4i. When I go after that second one, 2 times negative 3 gives me a negative 6. But I have an I times I here, so that's going to give me a negative 6i squared, right? That I squared is an I squared. That I squared is, so I have 4i minus 6 times negative 1. Well, that ends up being positive 6. So I have 4i plus 6. And I'm going to rewrite it in a plus bi form.
So we gotta flip, like,
Yeah.
Yeah, because it'll, like, if you're doing this and you have this on your scratch paper and you look at a multiple choice, it's going to be like this. Okay?
And like that.
No, this wouldn't be on there. Just
You're
one.
not gonna try it out?
No, I'm not trying
Okay,
to.
cool.
I had to make sure.
But, I mean, a lot of times, this right here will be on there. Because I'm checking to see, do you remember? You can't leave it as I squared because I squared is negative 1, right? So this will show up on your scratch paper and it'll show up in that multiple choice. So be careful. All right, what if, let's do a full binomial times a binomial. We'll say 3 minus 4i times 2 plus I. So first I get 6, 3 times 2. Outside, I got a positive 3i. Inside gives me a negative 8i. And last gives me a negative 4i squared. Now my two inside terms give me a negative 5i. But what is negative 4i squared equal to? There you go. That's actually just a plus 4, right? Because that I squared is a negative 1, so negative 4 times negative 1 changes that. So instead of 6 minus 4i, I've got a 10. Yes? All right. All right. Dividing. Now remember when we had, let's say x squared minus 9, we knew that factored the difference of squares to x plus 3, x minus 3, right? What was the thing about this? How come I could do these two binomials and only come out with 2 terms instead of 3 on this one? What happened to my center terms when I FOIL this out? I get that x squared. I get that minus 9 on the end. But inside, I've got a negative 3x. Because my signs are different, I have a positive 3x, right? So when I have the same terms but different signs, my inside terms always end up canceling each other out, okay? And I got to use that. When I'm looking for getting rid of, that's supposed to be a J, all the I's, I want to use this fact. I want to use something I already know. The difference of squares is going to help me out. I want to use the conjugate. The conjugate of 3 plus 2i is going to be 3 minus 2i. Whatever the sign is, I'm going to swap the sign, okay? Only this center. I left the 3 alone, positive 3, positive 3. Left it alone. I just changed this center term. It's still a 2i, but instead of a positive, it's a negative. And if this was a negative, then I would be writing a positive. All right? That's called the conjugate, just using the different sign. Now, what's going to happen? Why do I want to do it? Because I want to eliminate all those i's. I want a number here with no I in it. My center terms are going to cancel each other out. What am I going to end up with in my last term? I'll end up with that I squared, right? And the I squared is just going to become a number. So let's FOIL this out. I got 3 times 3 gives me a 9. Outside, I've got a negative 6i. Inside, I have a positive 6i. And then last, I have a negative 4i squared. Well, here we go. These are gone. Negative 6i got canceled out by positive 6i. I have a 9 plus 4. Because that I squared, that's that negative 1. So negative 4 times negative 1 gives me that positive 4. And I get to 13. And I have now eliminated all of my i's. Okay? And they say use the conjugate to eliminate those. Okay? All right. So how would I use that? I might have 10 over 3 minus 4i. Okay, so they don't like it to have any i's in the denominator. That's not a good thing. So I'm going to use the conjugate. What's the conjugate of 3 minus 4i going to be? There you go. Now, it's a fraction. So I can't just go changing the bottom. Whatever I do to the bottom, I have to, right? So to simplify this, I got to distribute that 10. So I've got 30 plus 40i. 10 times 3, 10 times 4i. Now, 3 times 3 gives me 9. 3 times positive 4i gives me a positive 12i. Negative 4i times 3 gives me a negative 12i. And negative 4i times positive 4i gives me a 16i squared. I'm sorry, that's wrong. Y'all call me out when you see me do. That's a negative, isn't it? What do my 12i's do? They're gone, right? And negative 16 times negative 1 becomes a positive 16. And 9 plus 16, 30 plus 40i over 25. Is there anything else I could do to that? Anything?
5 by 5.
Divide by 5, right? That can be simplified just like any fraction because it comes out of all 3 terms. So I'm going to say 6 plus 8i over 5. Yes? All right, let's try that one more time. I'm going to make it a little harder. Aww. All right, so let's try one. And you're going to have to FOIL it out twice. Okay, my conjugate is gonna be what?
1 minus
There you go. Alright, so I'm gonna have to FOIL on both the top and the bottom. So I've got 6 minus 6i,
no, minus 1
uh-huh,
plus 5.
squared, right?
Ah,
Okay, then plus I squared becomes a minus 1. So 6 minus 1 gives me a 5. Negative 6i minus 1i gives me a negative,
Don't want a negative
which one?
at first. The negative I squared.
So because both of them are negative, they'll
I
become,
didn't realize that.
yes?
Yeah.
Okay, so then I've got minus 7i. I will do that. I will make mistakes up here. Call me out. If you catch me making a mistake, I promise I won't get mad. Say, shouldn't that be? Do it every time. I promise. It's a good thing. All right. 1 times 1 is 1. Minus 1i plus 1i minus I squared. Cancels. Minus I squared becomes a plus 1. So the whole thing is over 2.
I thought. So if I squared is a negative, it becomes plus 1. And if it's a positive, it becomes negative 1.
Because whatever number is here,
If it's
like that's a negative 1 right there, and then the I squared is another negative 1. And negative 1 times negative 1 gives me a plus 1. Okay? Now, the shortcut, after you practice it a little bit, is my numbers here are 1 and 1. And it's always going to end up being the sum of those squares. Like this, 3 and 4. What's 3 squared? 9, 4 squared. And 9 plus 16 is 25. It'll always end up being the sum of those squares. 3 squared is 9. 2 squared is 4. 9 plus 4 is 16. Okay? Now that doesn't help you with the numerator, but you know what the denominator should be every time. Okay? All right, let's try when we end up with we already kind of had one tonight. So what if I had 4x plus 8 equals 0. Let's stick that into the quadratic formula. A, B, and C. A, What happens when I get here? 4 squared is 16. But 4 times 1 times 8, that's a negative 32. Yes? So I have negative 4 plus or minus the square root of negative 16 over 2. So by the way, how many solutions will this quadratic have? How many x-intercepts will it have? If there's a
negative, if it's a negative, yeah, none.
exactly. There isn't going to be any, right? So it's either going to be looking like this, or maybe somewhere it comes down like that, but it's not going to cross that x-axis. Doesn't mean it can't be graphed. Just means it won't cross the x-axis when I do. All right, so instead of 16, though, I'm going to break that to the square root of 16 times the square root of negative 1. So I've got negative 4 plus or minus 4i over 2. Now that can reduce, yes? What goes into all three? It's got to be all three. If it's not all three, it's not going to happen. So I'm going to have negative 2 plus or minus 2i. Yes? Okay. Anywhere we need to revisit? Could we go back and do another one of those, them there